with the rationals we've been dealing with lately, we have only been simplifying them. We haven't been solving for them. We'd end up with the completely simplified version of it, but we would never solve for x. So now that we have this equal sign right here, we're going to solve for x. So the first thing you have to do when solving rational equations is you have to find the greatest common factor for all of the bottom numbers, not just the ones on each side of the equal sign, but all of them. So first thing that I want to do is I'm going to start to factor out I have to find something that I know all of these can go into. Well, these two are the same, so I know that those two both go into each other. So I'm going to start to factor out this right here by finding a greatest common factor. So I can see one right now is I can take a 2 out of this, so I take out a 2. Okay, so that's what it looks like when I take a 2 out. And me just by doing this, I can see that this right here is this equation right here. So what can I do to this equation to make it this equation? The only thing that's missing is this 2 right here. So now that I know that all I have to do to the bottom of this one is multiply it by 2. So if I multiply this by 2, I distribute it, it'll end up being 2x to the 5th plus 30x to the 4th plus, oops, not 30, 60x to the 4th plus 10x cubed. Does that look familiar? Try looking right there. That's the equation we have underneath all of them. And now that I just multiplied this number by 2, it's the equation I have underneath everything. But I can't just multiply the bottom, can I? If I multiply the bottom by 2, that means I have to multiply the top by 2. So, now, from now on, since we just figured out that this is the greatest common factor, I'm going to refer to this equation as GCF. Just so that I can keep this messy function right here out of the problem. I'm just going to try and use it as GCF. Okay, so now that I multiplied this by 2, I have to multiply this top part by 2. So 200x times 2 is going to end up being 400x. So now I'm going to have 400x over the GCF. Okay, so now my whole problem is going to look like that. This is what it looks like now. See, I put GCF underneath instead of having to write this thing the whole time. So now we're going to solve for x. So something that I can get rid of on both sides is the greatest common factor. So what I'm going to do, my first step for solving for x is going to be to multiply this whole thing, everything between these two brackets, by this number, by the GCF. So if this is all dividing by the GCF, and then I multiply all of them by the GCF, that ends up having a GCF times and divide at the same time, which makes it cancel all of these out. So if I take out all the GCFs, so I times this by the GCF, it takes out all the GCFs, and what I'm going to have left is 10x times x plus 3 squared. This was supposed to be squared. Earlier on my other slide, it was cut off. So I have that, and then I have 1040x, and then don't forget the plus sign, plus 400, because on this side of the equal sign, 400x. On this side of the equal sign, what it was doing was adding these two together. So now we got rid of the GCF, so there's no more dividing left. So now that we took out the dividing, we can now combine like terms. So 1040x plus 400x is going to end up being 1440x, and that's going to be equal to 10x times x plus 3 squared. Next, I'm going to divide both sides by 10x. So first these x's cancel out, and then 1440 divided by 10 is 144, and it's going to equal the quantity of x plus 3 squared. Now I take the square root, both sides. And remember, when you take the square root of something, you get two solutions. When you take the square root, you get two solutions because it could be positive or negative, so you get plus or minus 12 equals x plus 3. So now you have to set up two different equations right next to each other, because you have to solve for x for both solutions you can get for the square root of 144. So it's plus or minus, positive or negative 12. So this one's going to be negative 12. You got rid of these cancel out. So it's just left with x plus 3. So now you solve for x. Minus 3, x equals 9. And then minus 3, x equals negative 15. Now, once you get your two answers, a way you can check to make sure you don't have an extraneous solution is you just plug in what you got for x back into the equation. So, if I just put these all together, I'm going to go up and use this equation. This equation right here. So I'm going to go and put it down here. So first I'm going to do the 9. Okay, so 10 times 9 plus 3 squared ends up equaling. Make sure you put 9 where all the x's are in the equation. See, I forgot to put this 9 right here. So once I just calculate out this side, I end up getting 12,960. Now when I calculate this side by putting 9 in for x every time, I end up getting the same thing. So this one checks out. I know that this is not an extraneous solution, because if it was, these two values would not be the same. Now let's do the same thing except putting 15 in. Now I just did the same thing except I put in negative 15 in for x. And on this side, I calculated it out. I ended up getting negative 21,600. And then on this side, I end up getting the same thing, negative 21,600. So this one checks out too. You should always do this to make sure you don't have any extraneous solutions. If these two numbers do not end up equaling each other, then you know that that solution is extraneous. And that's the whole process you have to go through in order to solve rational equations.